So the 3-2 videos are brought to you by the Viking King. He almost looks sad, doesn't he? His little eyebrows there. I mean, he's very strong. It must be the responsibilities of a king. Okay, compound interest is the subject of 3-2, and what we already know from Unit 2 is that compound interest is exponential, which came in this form: y equals some y-intercept, some initial value, times a factor, probably a growth factor, raised to an x value. What we're going to do now is rewrite this in the language of financial things using future value and principal and the rest. And we're going to note how it's repeated multiplication. So our author begins down here at the bottom of the page with the simple interest table and reminds us that, remember, simple interest, you earned a fixed amount of interest over the length of the investment. So we were given the $600. However we got it, we invested it at 5% simple interest. That meant we earned $30 per year. That remained unchanged. So after 2 years, it was 30 plus 30, $60. Add that to the account balance. Well, when it comes to compound interest, what happens is we now get to earn interest on that interest. So the author says, hey, calculate the interest on the $600 and the $30. Well, we already did this. We'll do it again for the millionth time. So there's the $30 of the 600. Here's the $30 that then was deposited into the account after the first year. And the compound interest says you get to earn 5% on the $30 the bank gave you. That ends up being $1.50. So your total interest earned after year 2 is $31.50. In other words, you earned an extra $1.50 because of the compounding. Well, then the author says, hey, do it again, but now do it with an initial amount of $630. So instead of separating that calculation, just do 5% of $630. Okay, fine. Here it is. Same calculation. Yep. Great. All right. I then screwed this up. I made this video and I was doing all this, but I screwed up how we add things. So I got to redo it. So the author says, well, let's rewrite the table for a compound interest thing. So we have our time. We deposit, at time 0, we deposit $600 and we have 0 interest. After 1 year, we will have earned $30 in interest because it's 5%, and our account balance will be $630. Note that compound interest after a 1-year time frame gets you the exact same amount of interest. Well, in year 2 is where it changes. We already got that. We're going to add in $31.50, not $30, so we end up with $61.50. We're going to add that back to the initial amount, and we get $661.50. Well, then things become annoying, because for year 3, to get the amount we need to add to the $61.50, we've got to find 5% of $661.50. Well, we have to multiply that by 0.05, and we got to calculate that. Well, we need to do that for the next couple years. Let's see, our table says for 3 and 4. I'm going to scamper over to Desmos and do that. So I'm taking the $661.50, which is the account balance after year 2, and I'm going to multiply that by 5%. That means after year 2, we will now earn $33.07 in interest. Well, maybe $33.08 in interest if they're kind and round for us. We're going to add that to the $61.50 we'd already earned. So after 3 years, we will have earned $94.57 and 5/10 cents in interest. That makes our account balance after 3 years this amount: $694.57 and 5/10 cents. Well, then to get the 4th year's amount of interest that we earn, we have to take that new account balance, 694.575, multiply that by 5%, and there's the new amount of interest we earn, $34 and approximately 73 cents. Well, we need to add that to the already accumulated interest from the previous 3 years, which happens to be the 94.575. Oops, I got to put a plus sign there. And here's the total interest we would have earned after the 4 years. The account balance then after 4 years is this amount added to the 600 that we initially deposited. $732 and approximately 30 cents. Okay, so here's the difference between compound and simple interest. Let's actually go back and compare this to what was the account balance after 4 years for simple interest. $720 versus this new amount of $732.30. It was an extra $12.30 over a 4-year period. Not super amazing, but we didn't have to do anything. So a nice increase. So what's actually happening there? How could we calculate that faster? And what we were really doing there was what's called an implicit formula, or sorry, a recursive formula, where we had to calculate the previous amount to then calculate the new amount. And it's a super tedious way of doing calculations. It's actually a common way that computer programs are written, which is great for computer programming, but not for us. We already did this in Unit 2. What we were doing is we were taking the value for year 1, and we were doing this 600 times 1 plus 0.05. Essentially, we were using this version of the simple interest formula. Well, then this was the year 1 amount. And then we were taking that and saying, well, this becomes the new year 2 account balance. And so we're going to multiply that by 1 plus 0.05. And this total amount becomes the year 2 balance. And then we're doing that again times 1.05, and all of this became the year 3 balance. And if you recall from Unit 2, when you multiply by the same thing, that's a repeated multiplication can be simplified into exponents. So this would have been the same thing as 600 times 1 plus 0.05 to the 3rd power. And of course, 1 plus 0.05 is really just 1.05 to the 3rd power. And that's what our author is showing here. We could just keep writing it this way. So if we wanted to do for 4 years, we could do 600 times 1.05 to the 4th power. For 5 years, 600 times 1.05 to the 5th power. If we want a t amount of years, meaning any number of years we want to use, we would just put a t there, and we could calculate as many number of years as we wanted. Turns out that is the compound interest for any amount of any value that is compounded annually. And what we mean by annually here, it's a very special word. It means once per year. This formula turns out to be not particularly useful because lots of times we compound more often than once per year. If you look at your savings accounts, you're probably compounded monthly. So interest is added to your savings account each month, and then interest is calculated off of that interest. Your credit cards are, many of them are compounded daily, although the fee isn't actually added to your account balance until the end of the month.